Python easily outperforms traditional spreadsheets when it comes to analyzing massive datasets. But before it can calculate a single return on investment, we have to learn how to translate our business goals into a language it actually understands. A computer is, at its core, incredibly fast but entirely literal. If you plug it in, it sits there. It is a black box that does absolutely nothing without precise, coded instructions from human programmers. Every set of instructions relies on a universal framework. First, there's input, getting the raw data. Then comes processing, where the computer manipulates that data. Finally, we have output, where the system communicates the final results back to us. Think of an everyday online shopping cart. When a customer is selecting their items and typing in their zip code, they are providing the system's input. The processing phase happens behind the scenes. The code tells the computer to multiply the item cost by the quantity, calculate the subtotal, and look up the specific state tax rate. The output is what the customer finally sees, the final cost displayed on their screen. Mastering Python means translating fluid business workflows into this rigid three-part architecture of gathering data, transforming it, and delivering a result. Before writing a single line of Python, programmers map out decisions using the program development cycle. They rely on visual flowcharts, using specific symbols like diamonds to map out where a decision must be made, and rectangles to show where a process occurs. Once that logic is charted out, the program needs a place to hold the data it will work with. It stores this information in designated memory locations known as variables. Because computers store different kinds of data in completely different ways, Python has to know exactly what type of data a variable holds before it can run calculations on it. This customer profile stores its name as stream data, meaning plain text. Their age, a whole number, is an integer. Their account balance, including decimals, is a float. And their newsletter subscription is saved as a Boolean, meaning it has exactly two possible values, true or false. If you try to add a string of text to an integer, the program will crash. Categorizing these data types ensures the computer can accurately apply your business rules without breaking down. With the data stored correctly, the program actually runs using just three basic structural constructs. The first is sequence. This simply means the computer executes its commands in a strict top-to-bottom order. But strict linear order isn't always enough. The second construct is selection, or branching. This allows the computer to evaluate a condition and make a choice using conditional statements known as if, elif, and else. This promotional pricing structure uses conditional logic. If a customer spends over $500, the program applies a 20% discount. Elif they spend over $200, it applies a 10% discount. For anything else, we use else, charging normal price. These selection structures allow a script to execute a human manager's judgment calls instantly across millions of transactions, ensuring every customer is treated exactly according to the defined logic. The final basic construct is repetition, commonly known as loops. A counter-controlled loop allows the program to take a single business rule, like calculating payroll tax, and automatically execute it exactly 1,000 times. To keep these massive operations organized, programmers bundle useful chunks of code into reusable modular blocks called functions. Instead of rewriting the formula every time, you write it once, label it as a function, and call upon it whenever you need it. When dealing with massive data sets, Python also needs a way to handle all that information efficiently. It temporarily stores groups of related items together in designated structures called lists. This visualization shows how these elements combine. Python imports a CSV file of previous marketing campaigns and converts it into a structured list. It then takes that entire list, passes it through a custom return on investment function, and outputs the calculated metrics. By combining lists, loops, and functions, a programmer takes a single mathematical solution and scales it across millions of data points without any manual intervention. For decades, the image of the isolated programmer at a terminal defined coding as a niche, purely mathematical task, separate from the business world. But these variables, selection statements, and loops are actually digital versions of the workflows managers use every day to make strategic decisions. Whether you write your own analytics scripts or manage a team of software developers, understanding these basic constructs is required for anyone working with data. Having a solid grasp of how logic flows through a program gives you the ability to bridge the gap between high-level management strategy and technical IT execution. Think about your most tedious task at work. Consider how a simple Python loop or selection structure could take that workload off your plate today.